class, this is Coach Riza. For today, we are going to talk about the universe and the solar system, Part 1. Have you ever wondered, or have you ever asked yourself, how the universe started? Yan. So, natanong nyo ba sa inyong mga sarili, no, kung paano ba nagsimula ang lahat? Paano nabuo ang mga planeta, mga galaxies, and other entities existing in our universe? So let's find out the origin of the universe. So, one of the greatest mysteries of the universe is its origin, since no one witnessed the actual beginning of the universe. Scientists can only reconstruct the events based on the evidence that are available. Thus, many theories have been proposed. So, for the origin of the universe, marami tayong mga ideas or maraming mga ideas na na-come up ang ating mga scientists. And way back no, sa mga nung unang panahon, ancient philosophers natin also gave ideas, their own ideas about how the origin or how the universe started. But we are going to talk about only one for this topic. Okay, so let's begin. Once upon a time, there was nothing, not even time, space, matter, not even light. Okay, so nung unang panahon daw, no, wala pong kahit ano sa ating universe until this happened. The Big Bang. So the Big Bang Theory describes the development of the universe from the time just after it came into existence up to today. It's one of several scientific models that attempts to explain why the universe is the way it is. As I have said a while ago, maraming scientists ang nagbigay ng kanilang ideas, theories, models, scientific models, no, about how the universe or about the existence of our universe. The Big Bang Theory, it is the most widely accepted and popular theory to explain the origin of the universe. Bakit siya yung widely accepted? It's because there's a lot of evidence that was provided by our scientists, discovered by our scientists, that proves that the Big Bang happened. Okay, so let's find out now the Big Bang Theory. So the Big Bang Theory, while many people believe that Big Bang Theory refers to an explosion, it actually refers to the expansion of the universe. So, isa sa mga misconception kapag naririnig yung Big Bang Theory is that the Big Bang daw is literal na Big Bang, an explosion. And from that explosion, nagkaroon ng universe. But it's not like that. It actually refers to the expansion of the universe. Ang ating universe, bago ito maging universe of today, dumaan ito sa stages of development. Hindi lang siya bigla na lang sumulpot out after an explosion. Okay, so marami siyang pinagdaan ng development habang ito ay nag-e-expand. That is why it is the expansion of the universe. So tingnan natin yung stages of development na pinagdaanan ng ating universe through the Big Bang Theory. Okay, so here, the Big Bang Theory again is the event about 13.7 billion years ago. So imagine, it's 13.7 billion years ago when time, space, matter, and energy came into existence. This event started from a hot, dense state that has undergone inflation. So when we say inflation, it is a short but rapid expansion to become the universe that is known today. So as I have said a while ago, once upon a time there was nothing. That is why the universe started from nothing until there was only pure energy compressed in a single point called the singularity. So that singularity or that single point is the event that started for our Big Bang, the hot, dense state. So, yun po yung tinutukoy niya, the hot, dense state of pure energy compressed in a single point, which is called the singularity. So doon nagsimula ang lahat, from that single point, from that what we call the singularity. So let's find out the development, or how from a singularity expanded to the universe that we know today. So here is the illustration that provides the explanation of how our universe expands and develops into the universe that we know today. So the Big Bang Theory. So let's go first from the very beginning of when it all started. So it begins again from a single hot dense point that we call the singularity. And time begins at 10 raised to negative 43 seconds. On that span from 0 to 10 raised, or not really 0, but it's a fraction of a second, a very tiny fraction of a second, not even 1 second. This happened. So the cosmos, now number 1, the cosmos goes through a super fast inflation. Okay, from our singularity, it goes through a super fast inflation, expanding from the size of an atom to that of a grapefruit in a tiny fraction of a second. So class, just imagine, no? The atom, the size of an atom is the size of our singularity. And take note that the size of an atom cannot be seen by our naked eye. Right? So, sobrang liit nung singularity na yon. Nagsimula siya sa sobrang liit. And in a tiny fraction of a second, it expanded into the size of a grapefruit. Now, moving on to our second part of the development of our universe. At the time, 10 raised to negative 32 second. Again, tiny fraction of a second, no? So, wala pang 1 second. Okay, so continues ang development ng universe. Post-inflation, the universe is a seething hot soup of electrons, quarks, and other particles. So at that time, our universe is super hot. Sobrang init ng temperatura ng ating universe. So, kaya niya describe it as seething hot soup of electrons, quarks, and other particles because from our singularity, nag-start ma-develop yung other particles of matter. So, those particles are the quarks and electrons and other particles. So, puro quarks and electrons yung unang mga nabuong particles of matter. And then going to the third part of our development is that time, 10 raised to negative 6 second, again, a tiny fraction of a second, wala pang 1 second. A rapidly cooling cosmos permits quarks to clump into protons and neutrons. So that time, no, unti-unting rapidly pa lang lumamig na ang ating cosmos. Okay? Lumamig konti ang ating universe. And because of that, no, it permits the quarks to clump into protons and neutrons. So, clump together na yung mga quarks natin, forming the protons and electrons. And again, it's a continuous process all throughout our universe. Yung pagkabuo ng mga quarks, electrons, protons, and neutrons. And take note, class, that these happened only at 1 second. Okay? So, yun po yung ganap. No, yung mga nangyari, just a tiny span of tiny fraction of a second until 1 second. So, time skip after 3 minutes. So, sabi niya dito, after 3 minutes. So, number 4, still too hot to form into atoms. Charged electrons and protons prevent light from shining, and the universe is a super hot fag. So, at that time, now that after 3 minutes, so, medyo mainit pa din daw ang ating universe para mag-form pa ng other type of matter. So, that time, the universe doesn't have light. So, it is also called the dark ages. That time is also called the dark ages of our universe. So, super hot fog lang daw siya, composed of the electrons, protons, and neutrons. time skip again, no? During the time span of a few minutes to 300,000 years later. Again, this is a continuous process from the beginning up until to 300,000 years later, no? Electrons then combine with protons and neutrons to form atoms. So mostly, hydrogen and helium yung unang mga elements na na-form. So then, from then on, light can finally shine. So unti-unti nang nabubuo yung mga atoms natin, yung mga elements natin. And the first two elements are hydrogen and helium. And we all know that hydrogen and helium are both in gas state. So if related to chemistry, the hydrogen and helium is gas state. Okay? So thousands of years later to a billion of years later, gravity makes hydrogen and helium gas coalesce to form a giant clouds that will become galaxies. Smaller clumps of gas collapse to form the first star. So after a billion of years pa, nag-start mag-form ng giant clouds of hydrogen and helium gases. And those gases coalesce. It means to say that it's starting to clump together to form the galaxies and the stars. Okay, yung mga galaxies natin, planets natin, and the stars. And after billions of years later, up till the present, so dun na, from that billions of years later, nag-unti-unting nabuo yung mga planeta, galaxies, stars, and other entities, other matter within our universe, up to the present. So our universe is still continuously expanding at the moment. So at number 7, as galaxies cluster together under gravity, the first stars die and spew heavy elements into space. Thus will eventually turn into new stars and planets. So again, the planets were made. The planets were made from our gas of giant clouds of gas, and the galaxies were formed and the stars were formed. So that's how our Big Bang Theory started and developed into how our universe is today. Okay, so there's a lot of illustrations regarding the Big Bang Theory, but I picked this one because it's much more easier to understand. So let's move on to the next slide. So we have here another illustration of our Big Bang Theory. So it's the same. It's the same as this one. Okay. So it all started from the singularity, the Big Bang, and then it undergoes inflation. Again, inflation is a short but rapid expansion. And the other details regarding the Big Bang, the dark ages, the first stars, the formation of our galaxies, and other matters within our galaxy. So that is our Big Bang Theory. Now, sino ba nakaisip neto or sino ba nagbigay ng idea neto? No? Ito na nga, si George Lemaitre. So the idea of Big Bang started in 1972 when George Lemaitre, a Belgian physicist and a Catholic priest, deduced that if Einstein's general theory was true, the universe must have been expanding. So again, the idea of Big Bang was proposed by George Lemaitre, but the ideas of the expanding universe and the evidences was given by other scientists. So, ginamit niya yung mga evidences na nakalap din ng other scientists to his idea of Big Bang. Okay, so let's see those scientists, piling mga scientists na nagbigay evidence of how our universe is expanding and gave a proof of the idea of the Big Bang Theory. So let's find out. First is, of course, Albert Einstein. and his theory of general relativity. So, he determined that the massive objects cause a distortion in space-time, which is felt as gravity. So, what he's talking about here, the massive objects, is the planets and the other entities or matter in our universe. So, of course, our planets, the planets in our solar system, is massive and it has mass, of course. And because of that mass, the mass of those objects cause a distortion in the space-time. Okay? So, another thing that he proposed is the static universe. So he said that the universe was static and the galaxies were moving inside. So, tingnan natin no, yung another explanation of the theory of general relativity. So it is this one, the illustration rather of the general theory of general relativity. It's like this. So the region, the region there, as you can see on the illustration, is curved because of the presence of a matter. And for his illustration, the matter that he's talking about was the ball, yung bola doon, yung metal ball. So this region, if you can see the second arrow, is curved because the region near the object, the metal ball, no, is curved. Because again, the metal ball is heavy. Okay? And that caused distortion to what he called the space-time. So space-time can be thought as a reed or a fabric, like on this model. And the presence of mass distort space-time, yung tinutukoy niya. Okay, he also have equations for this, and he also calculated the distances between the different planets and so on. And because of that, no, the idea of calculating the distance made it easier for Lemaitre to conclude that the universe is expanding. So he used Albert Einstein's idea, the theory rather of general relativity. Next scientist is Alexander Friedmann. So Friedmann's equation. So he proposed his own equation. He's a Russian cosmologist and mathematician, derived the Friedmann equation from Albert Einstein's equation of general relativity. So he kind of enhanced Albert Einstein's equation from his theory of general relativity. And through this equation, it shows that the universe might be expanding. Through their equation and computation, it shows that the universe might be expanding. So here is his equation. So, ayan. So, he also gave proofs, his equation, parang nagbigay ng proof that the universe is expanding. Okay? So, yan si Alexander Friedmann. He also proposed other theories about our universe, but we're not going to talk about that. Yeah. So, next is Vesto Slipher. So, in 1912, an American astronomer was the first to observe the shift of spectral lines of galaxies, making him the discoverer of galactic redshifts. So, ma'am, what is this galactic redshifts that we are talking about? So, when we say redshift, it's the wavelength of light that is stretched. So the light is seen as shifted towards the red part of the spectrum. So later on we will see an illustration regarding this redshift. So he noticed that redshifts provides the first empirical basis for the expansion of the universe. So paano ba niya to ginamit? So let's find out. So Vesto Slipher used the Doppler effect. So the Doppler effect is more on the sound waves. So he measured the first Doppler shift of a spiral nebula. So the spiral nebula is an obsolete term for spiral galaxies, and soon discovered that almost all such nebulae were receding from Earth. So nasabi niya, based sa kanyang na-research, based sa kanyang na-pick up, na measured na Doppler shift, shift is that napansin niya, no, nalaman niya na yung mga galaxies which they called before as spiral nebula ay papalayo sa Earth. So, paano ba itong Doppler effect na ito? At paano pa niya na-conclude na gano'n yung nangyayari? That the universe is expanding. So, here it is. Let's say you are standing at the middle of a road. Not literally, but somewhere at the sidewalk of the road. And may dumaan na ambulansya. Kapag may dumaan na ambulance or ambulansya, at may siren or naka-on ang siren, kapag ito ay papalapit sa'yo, ang naririnig natin na sound ay high pitch. So, it gives us, or the sound gives us a high frequency na sound. At kapag nakalagpas naman ito sa atin, binibigyan naman niya tayo or naririnig naman natin ay ang low pitch or low frequency na sound waves. And from that, yung sa first na na-measured niya na Doppler shift, no, from the spiral nebula is that low frequency yung napipick up niya. Ibig sabihin, kapag papalayo yung object sa'yo, no, low yung mapipick up mo. That is why nasabi nila na papalayo from the Earth yung spiral nebula. It means to say that the universe is expanding. So, yun yung discovery ni Vestal Slipher. Okay? So, next is si Edwin Hubble. So, noong 1929, si Edwin Hubble announced his significant discovery of the redshift. Although, nung una, si Vesto yung una talagang naka-observe. Pero hindi niya, in-announce as his own. So, noong 1929 pa, no, kay Edwin Hubble, announced a significant discovery of the redshift and its interpretation that galaxies are moving away from each other, hence as evidence for an expanding universe. So, yung redshift, sabi ko nga kanina, ay wavelengths of light. Okay, so that redshift no, serves as evidence for an expanding universe. So, paano po ba yun nangyari? So, tingnan natin to. So, as you can see, the picture on the left side is a man using his equipment. So, yun yung equipment na ginamit nila to observe the shifts of light no, from our galaxy. So, as you can see on the first part, if a galaxy is moving towards an observer, so yung emissions sa spectrum, ang napipick up nila ay shorter wavelengths. Ang napipick up nila na color is yung color blue from the spectrum. As you can see on our right side, we have this what we call the visible portion of an electromagnetic spectrum. So the visible light that they can see from their equipment. So if papalapit daw sa atin yung object, or the galaxy rather, to Earth, we call this blue shift. If the galaxy is moving away from an observer on Earth, we call this redshift because the wavelength is longer and the color or the visible light that they could see is the red part. Okay? The red part of the spectrum. And because of that, the things that they have observed is that longer wavelengths yung napipick up nila. So, redshift siya. And it means to say that the galaxy is moving away from an observer on the Earth. So, that made him conclude that the universe is expanding. Last but not the least, yung nagbigay ng evidence regarding kay Big Bang is si Arno Penzias and si Robert Wilson. So in 1964, Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background, which earned them the Physics Nobel Prize in 1978. So the cosmic background radiation is the radiation left over from early development of the universe, and it is a proof of the Big Bang theory. So imagine the cosmic background radiation happened way back 13.7 billion years ago when the universe started. And because of their research, they somehow accidentally discovered this cosmic microwave background, which happened billions of years ago, pero na-pick up nila from their equipment. And from that, they concluded that this is the proof of the Big Bang theory, that the Big Bang did happen. So those scientists that I have mentioned and their discoveries, their discoveries about the Big Bang and the expansion of the universe, yun yung ginamit ni Lemaitre, ni George, in his idea of the Big Bang theory. So those are the evidences that proves that the Big Bang theory did happen and that our universe did expanded and still continuously expanding up until today. So now let's move on to our next topic, which is about the fate of the universe. Ano kaya ang mangyayari pagdating ng araw? Ano kaya yung mangyayari sa universe natin? Or ano kaya yung magiging ending ng ating universe? So again, our scientists come up with ideas regarding ano ba yung magiging fate ng universe natin. So the evolution of the universe according to the Big Bang theory, first is the Big Crunch. So this theory postulates that the average density of the universe is enough to stop its expansion. Then the universe begins to contract at a single point. It implodes. So, paano yun, ma'am? Anong ibig sabihin nun? So, ito yung sinasabi ni Big Crunch. Darating daw yung point wherein mag-stop yung expansion. Okay? So, darating daw yung point na yung universe natin ay titigil sa pag-expand niya. At pag dumating tayo sa point na nag-stop na yung expansion, babalik daw ito pabalik sa kanyang single point, sa singularity. Magre-rewind back siya ng prosesong pinagdaanan niya. So that is our Big Crunch. The next one is the Big Freeze. The Big Freeze, the expansion of the universe will continue forever. Sabi ni Big Freeze, forever daw mag-e-expand ang universe natin. If so, the universe will cool as it expands, eventually becoming too cold to sustain life. Dahil continuous ang pag-expand ng ating universe up to forever, because of that continuous expansion, lumalayo sa isa't isa ang mga galaxies. And because of that, lalamig ang ating universe. The universe will cool. And because it's cool or too cold, hindi na kayang masustain yung life. So that is our Big Freeze. And last but not the least is our Big Rip. So ito daw yung possible na mangyari or fate, one of the possibilities or the fate of our universe. The Big Rip. So the universe does not contract, but expands as it reaches a point where all that exists is broken, like a handkerchief in the hands of two children pulling hard on each to the opposite side. So sabi niya, sa Big Rip daw, the universe daw will not contract, but rather it will continues to expand until such point na mabibreak na lang itong universe natin, or all that exists in our universe will broke into two, or it will have a Big Rip. It will be broken. So that is our Big Rip. Ayan. So again, we have three fates of the universe: the Big Crunch, the Big Freeze, and the Big Rip. Is everything clear? Any question? If you have any question, just chat me on via Messenger or via LMS chat box. Thank you for listening. I hope you've learned a lot. Reminders: read and review our lessons, watch all video links, answer all activities. It's all posted at Module 1. Please do this during your asynchronous schedule for ELS. Again, thank you and hope to see you in our next class. Bye!